Super Mario, Super Mario, Super Mario! Hello everyone, welcome to this video. In this video, I'll be reacting to one of the videos from the YouTube channel The Game Theorists. I'm a huge fan of their work. I hope that you will like this video as well. So this video came out in the year 2018, I think it's around 3 years ago, and it's about Super Mario! Yeah! So let's watch it. Oh! Oh no! I mean, oh no.
Hello, Internet! Welcome to Game Theory!
Hello.
Spending more time analyzing fictional athletics than actually going outside. I know I recently said that Mario is classified as overweight according to the BMI scale, but one thing that BMI doesn't do a good job of factoring in is muscle mass.
Muscle mass. That's why BMI is sort of can be improved. Yeah.
Which is heavier than fat. And when you take a look at Mario, sure, he may appear like an adorable chubby plumber, but he in fact may be the most athletic character to ever appear in video games.
Not sure if you can read this, right? This is Chinese character, or you can also read this as Japanese character. Okay, kanji. Li. That means strength, muscle, strong.
I mean, he's appeared in 25 sports spin-off titles, competed in every single Olympic event both summer and winter, and mastered everything from golf and soccer to non-traditional activities like having Waluigi slowly grind up on him. Oh, Waluigi, you...
Oh, come on. Keep it family friendly, please. Wholesome.
Casual lover. You might not make the Smash Bros cut, but you'll always have a place on Mario's dance card. You'll be the challenger approaching from the rear every time. Mario's latest venture is Mario Tennis Aces on the Nintendo Switch, which loyal theorists may remember from that, other video I made back in April. Hey, you put those suggestive sound effects away, mister. But
Oh gosh, come on. Keep it family friendly, keep it wholesome, okay? Yeah.
at this point, I'm done rummaging my rulers through the Mushroom Kingdom sports shorts. Instead, today, I want to take a closer look at this game's coolest addition, Zone Shots. You see, during matches, players can fill up an energy gauge by rallying the ball. Then, with enough energy, you're able to hit a Zone Shot, a fast-moving spike that's near impossible to return. Near impossible. You see, that's where there's this brilliant little bit of strategy involved. You have the choice to either hit your zone shot into the corner of the court, where your opponent will have no chance at returning it, or shooting it directly at them. If you go this route, sure, they have the possibility of returning the hit, but if they miss, their racket may just snap in half, forcing them to forfeit the match entirely. Apparently, with Mario hoarding all the gold coins, no one can afford more than one racket in this universe. Anyway, this all got me thinking, is it actually possible to launch a tennis ball so hard that it can break an opponent's tennis racket? And if it can break a tennis racket, what other horrific things could that ball do? I know we've talked about how deadly some things in the Mario games can get, but could its deadliest weapon actually be a simple tennis ball?
A simple tennis ball from a game, a sports game. Wow.
Let's pull out our TI-83s and find out. As
Oh my god, it's gonna be nerdy.
with all games, we'll need to determine a census scale first and foremost. But, luckily for us, gaming's most reliable ruler, Mario Jumpman Mario, is here for us to use. At a
Yeah! The best ruler is actually Mario itself, so Mario equals to ruler. Yeah!
155 centimeters, Mario allows us to convert in-game measurements to real-life units, and shockingly, the courts in Mario Tennis Aces are surprisingly realistic. I found the in-game courts to only be a few centimeters apart from the dimensions of regulation-sized tennis courts, which are usually 78 feet long, 23.77 meters, and for singles matches, 27 feet wide, or 8.23 meters. I mean, the French Tennis Federation has already disallowed skin-tight bodysuits, so I would expect flying clown cars to also be deemed illegal in the game, but
It's like flying carts, nah, it's banned.
at least the court sizes are in accordance with the rule books.
Yay.
Also, the game does us a favor by providing the speed of serves in miles per hour, which is similar to what's done in real-life televised tennis matches. However, a seasoned theorist like myself knows to take these in-game speedometers with a grain of salt. So how does the radar gun in Mario Tennis Aces stack up? Using frame rates and more pixel measurements than I could shake a racket at, I found that the actual speed of any given serve was around 10% slower than the speed that was boasted on the radar gun. And while that might seem like Team Nintendo is simply juicing the numbers in their characters' favor to make things more fast-paced and exciting, the same thing actually happens in real-life tennis matches.
Oh.
The average speed of serves is always less than the speeds listed on television. And for once, it's not because we're intentionally being lied to. Instead, the radar reading is always taken right after the ball is hit. At that precise moment, the ball is traveling at its single fastest, before it steadily starts slowing down due to air resistance and spin. So unbelievably, Nintendo is actually 2 for 2 when it comes to accuracy in this game. And
Ooh, wow, that's really impressive. It's like accuracy.
we might as well make it 3 for 3 because I also checked gravity based on the speed of the falling tennis ball during serves, and that checked out too. 9.7 meters per second squared, which is pretty darn close to the real-life 9.8.
9.81.
Overall, this might be the single most realistic Mario game ever, provided you're willing to overlook the giant sentient ball of metal that's allowed to play tennis.
Giant sentient metal ball.
Taking a closer look at how the tennis rackets break in the game, even before doing any calculations, one
gosh.
big concern stands out to me. If you zoom in during a successful zone shot, you can clearly see that the racket is breaking at the handle, the thick part where the player is holding the thing. This is an enormous red flag because in real life, when rackets break, they almost always occur at the strings, frame, or neck. Physically
Yes.
speaking, this
The strings break, the frames break, the necks break more often than the handles break. Yeah, so the more you know in real life. Yeah. Yay.
makes the most sense because they're the weakest part of the racket and are thus the first to break when any sort of force is applied, either by the ball or when the player decides they need to rage quit. And oddly enough, in the image that eventually went viral for other reasons, Nintendo shows Luigi's racket breaking at the correct point, the strings and neck. But apparently it was just too hard to implement into the actual gameplay, and so we're stuck with what's depicted in the game, which I guarantee is gonna yield us some absurd numbers. Now, you might remember from the Blue Shell episode that impulse is one method of determining the force transferred by a projectile. That's the measurement here that's gonna help us determine whether a ball can break the racket. Impulse is equal to force times time.
Impulse equals to force times time. So if the time is long, the force can be small. But if the time is short, the force must be high. So something like that, something similar to that.
It's also defined as the change in momentum,
Change in momentum. J equals to F times T equals to differential of P.
which, for a ball traveling in one direction and then being hit in the other direction, is going to be pretty darn easy to find. Momentum is equal to speed times mass. So we need to find the mass of the ball, speed headed into the racket, speed headed the opposite way away from the racket, and the amount of time the ball is actually in contact with the strings, giving us a total of 4 unknown variables that are all pretty easy to find. We first have to assume that the ball has a regulation mass of a tennis ball at 58.5 grams.
That's the unfortunate thing. We have to assume on some things, like for example, the mass of the tennis ball. Yeah.
But considering how realistic the measurements already are in this game and the fact that the ball behaves similarly to a real ball on 3 different styles of court, this isn't that hard of an assumption. The speed of the ball can be calculated using frame rates and pixel measurements just like we've been doing all episode, and we get that it's traveling 96 miles per hour before impact, 43 meters per second, and 28 miles per hour, 12.7 meters per second, in the other direction after being hit. So with all those numbers in place, we're able to calculate the change in momentum. Final momentum minus original momentum. Because mass always has to be in kilograms for this, we shift the decimal point over a few places, which is always like the most obnoxious part of these sorts of physics equations, keeping your units together. I just gotta say that to express what I'm sure is the feeling of countless students taking high school physics. I would say more points and half points are lost on tests that way than any other way. And speaking of those really minor things that are always super obnoxious to keep track of, this is the thing I always have to remind myself when it comes to momentum. The ball is headed in opposite directions before and after the impact, which means that one velocity has to be positive and the other one has to be negative. I mean, think about it this way. If they were both positive, that would just tell us that the momentum had slowed down, but it was still in the same direction, which obviously isn't the case. The total velocity change was the speed going into the racket plus the addition of 12.7 meters per second added to it going in the opposite way.
So thus there is a difference of total velocity change because there's a plus and a minus involved, which will be very complicated if you don't understand this well.
So in total, the whole thing changed speed by 55.7 meters per second. Does that all make sense? Welcome back to school, everybody.
Welcome back to school, everybody. Yeah!
Tell your math teacher about this episode. Maybe you'll get to watch it in class. Anyway, doing the math gives us 3.26 Newton seconds, which is stupid and means absolutely nothing to any normal human being. So let's put it into terms that actually make sense. To do that, though, we're going to need to know the impact time, which is as simple as counting the frames that the ball is in contact with the racket. It's only 3 frames, and at 60 frames per second, that translates to 0.05 seconds, which again, shockingly is about how long a typical tennis ball in real life will be in contact with a racket's string. Mario Tennis Aces, ladies and gentlemen. I'm giving it the award now. Nintendo's most realistic game. Boom, there's the sticker.
Most realistic Mario game! Yeah! Awesome.
Slap that one on your box art. Interestingly enough, this 0.05 number tells us that Mario and the crew are pretty much professional level tennis players. You see, players can control the impact time between the ball and the racket by adjusting the stiffness of their string bed. Beginners might not be able to hit the ball with a whole lot of strength, so they'll typically use a racket with a soft and low tension net to increase dwell time, the length of time that the ball is staying in contact with the strings. This in turn enables a sufficient impulse to bounce back the ball at a high speed, but it comes with a price, a loss of control. In contrast, professional players are already striking the ball at full strength, so they tend to prefer a racket with a tight net to shorten their overall impact time, closer to the times that we see present in Mario Tennis Aces. For them, it's all about spin and trick shots. In fact, many will actually keep 2 or more rackets on hand with different string bed tensions so they can actually change strategy mid-game. Anyway, with all that—
Oh, that's clever! You can actually play with the strategy. You can change strategy, in fact. That's impressive.
information, we can determine that the ball during a zone shot in Mario Tennis is delivering 65 newtons of force onto the racket, which is really small. It's only about the force of an average cat sitting in your lap. So, how does that compare to the force required to break a tennis racket? Well, unsurprisingly, racket manufacturers don't really advertise how much force is required to break their product. But we can calculate a rough estimate of the force by looking at the racket's ultimate shear strength.
Shear strength, another term used by nerds.
Which is basically a measure of the stress that a material can withstand before it snaps. Looking at the Mario racket in-game, it appears similar to the rackets used by professional tennis players, allowing us to narrow the possible options down to 3 common materials: aluminum, titanium, and carbon fiber.
Or maybe this game is made of adamantium, adamantium or vibranium. It's a game after all, so it's fictional world.
In the shear strength equation, force is equal to the shear strength of the material times the cross-sectional area. This is why rackets in real life tend to break at the neck or rim, because of the smaller cross-sectional area, but again, as mentioned earlier in the video, the racket in-game breaks along the handle, so the cross-section area is 7.4 cubic centimeters. Adding to the difficulty of Mario's situation, most real tennis rackets are hollow. However, screenshots of the game as the tennis racket snaps in half clearly show that Mario's rackets are completely solid. Therefore, the entire cross-section is used in the equations, whereas it would be much less IRL. Now all we need to do is plug in the ultimate shear strengths of each suspected material to find the estimated force. Aluminum, with the ultimate shear strength of 207 megapascals, would require 153,180 newtons of force to break. Titanium, with an ultimate shear strength of 380 megapascals, would require 281,200 newtons to snap. And carbon fiber, with the lowest shear strength of 95 megapascals, would require 70,300 newtons to snap. Remember that the zone shot provided a mere 65 newtons of force, not 65,000, 65. Literally thousands of times less than would be required to actually break a racket. No matter what this racket is made out of, it ain't gonna break after a single shot, regardless of how much power Waluigi is getting from that rose in his mouth. However, this
The rose in the mouth. Wonderful!
of course begs the question, how fast then would the balls have to be hit in order to actually get the results we see in the game? So I worked backwards using everything we talked about today, and brace yourself. Even I.
Brace yourself. Math pet is coming. Get it? Get it? Because it's not Math pet, it's Math pet. With all the maths involved.
As someone who deals with absurd numbers all the time on this show, was shocked. In order to break the carbon fiber racket, the easiest of the rackets to break, the ball in Mario Tennis would have to travel over 134,000 miles per hour. That is 60,000 meters per second. The aluminum racket would require the ball to travel almost 300,000 miles per hour, 130,000 meters per second, and titanium rackets would need the ball to be hit at a whopping 500,000 miles per hour.
Around 500,000.
That is 240,000 meters per second. What would happen if a tennis ball traveled that quickly? Well, first of all, there's no way that you're getting a ball to reach those sorts of speeds in the first place.
Unless it's a game and because it's a game, maybe the tennis ball material is made of different. Material is like, maybe it's made of a fiction material like, as I mentioned before, adamantium or vibranium. You know, the usual stuff.
The world record for fastest ball is held by Samuel Groth of Australia, who hit a serve of 163 miles per hour back in 2012. Nothing short of a particle accelerator could make matter move that fast. Additionally, air molecules wouldn't have enough time to move out of the way of the ball, which would cause a nuclear chain reaction as our yellow little fuzzball slammed atoms together in front of it. Forget losing a tennis match and boo-hoo, I have a broken racket. No! The Mushroom Kingdom would be overtaken by literal mushroom clouds. The ball would not only KO the player like we see in the game, but likely kill every single person in the process. You, your opponent, the entirety of the stands. If you actually tried to return this thing, the fact that a tennis racket is a class 3 lever would mean that the force from the tennis ball would be 4 times greater as it surges up your arm. It's likely that it would disconnect your arm. Forget playing Mario Tennis, you'd suddenly be playing Happy Wheels. Add it to the list.
Oh my god! The Happy Wheels reference.
Loyal theorists, we've found ourselves yet another Mario game in which everyone dies. Oh, and about that sticker that I gave you, Nintendo's most realistic game, yeah, I'm just gonna take that back. Because when it comes to sports, Mario don't mess around. And when it comes to saving you money, Honey, our sponsor for today's episode, doesn't mess around either. Honey is a free shopping tool that automatically searches the internet for the best promo codes every time you buy something online. To show you just how good Honey is, I asked them to crunch some numbers based on the last time I mentioned Honey on the channel. So a few thousand of you installed it. Thank you very much. That actually shows that I'm a good partner to them, so they want to do more with the channel. It's great. Apparently, importantly though, those of you who did install it saved an average of $24.60 each. And in total, of everyone who's installed it from this channel, you guys have saved, get this, $388,835.51. Nearly $500,000 was saved by this free browser extension. Do you want to know the number one thing that you all saved money on? New Nintendo Switches. And can I tell you how happy that makes me? That is money for you guys staying in your pocket, allowing you to get more of the things that you want or get those things more cheaply. And we all know that times are hard these days and things are more expensive than ever.
Especially that is especially true because of 2020 hack 2021. Yeah.
Why not have Honey working in the background to help you save cash? Is literally just 2 clicks to install. Click 1 down there in the description, joinhoney.com/MattPat. Click 2, install, and boom, you're done. Step 3, profit. And it works on everything. Over 30,000 sites. I mean, sure, it'll save you huge amounts on your typical products from places like Amazon, eBay, Microsoft, Etsy, Walmart, Newegg, especially for making a big purchase and getting gaming and computer supplies, saving you sometimes hundreds of dollars, but it'll also save money on everyday things, like pizza. I mean, the other day I bought some basketball tickets to give to someone as a birthday present on SeatGeek, because you know I wouldn't be buying them for myself, and no joke, I didn't even think to check Honey, but it pops up and says, hey, save $100. It is literally that easy. It has over 10 million users and 90,000 5-star reviews. And why not? It is 100% free and pretty much uses itself. I know I promote a lot of products that I love on this channel, and some aren't applicable to everyone, but I firmly believe that Honey should be in everyone's browser. It saves you money and you do literally no work. So remember, get Honey for free today and start adding to that $400,000 saved by your fellow theorists. $400,000 back in theorists' pockets. 2 clicks. Click 1, joinhoney.com/MattPat. That's joinhoney.com/MattPat. Go! Get yourself that Switch or a new tennis racket. Or heck, with Honey, you can probably get both and still have some money left over for Theorist merch. So why are you waiting? Please don't take my word for it. Just save yourself money. I'm literally begging you to save yourself money. If you haven't figured it out by this point, I don't know what to tell you. You don't want to save money? Fine. That's fine. I get it, I guess. I don't get it. Things are so damn expensive. Next time I promote Honey, I'm going to talk to you about how the algorithms of these websites actually rip you off and how Honey can prevent that. That's a whole topic for another end card. And remember,
You wanna get ripped off? Because that's how you get ripped
that's
off.
just a theory. A game theory. The part about Mario's tennis rackets, not the part about Honey saving you money. Thanks for watching.
Alright, alright, thank you so much for watching this video. I do hope that you like this video as much as I do, because yes, I'm a huge fan of their work. If you do like this video, please consider to like, share, and subscribe to my channel, and comment down below if you have anything to share with us. And also comment down below if you have anything to share with us, and follow my channel as well. Yeah. And yeah, do check. I do recommend that you watch more of their videos from the YouTube channel, The Game Theorists. And I hope to see you soon. Again, thank you so much. But hey, that's just a theory. A game theory. Thanks for watching. Thank you. Super Mario, yeah! Tennis racket!